We'll now look at sludge treatment. This refers to the sludge evacuated from the previous tanks as part of the wastewater treatment process. This sludge comprises primary sludge, secondary sludge, and grease. Primary sludge is mainly composed of feces. The terms secondary or excess sludge define excess microorganisms that are removed from the treated water after the final clarification stage. The different types of sludge can either be treated together or separately. The first option is mainly used in smaller wastewater treatment plants. Here, primary and secondary sludge are treated together in so-called mixed sludge tanks, for example, 60% primary sludge and 40% secondary sludge. In sludge treatment, water is removed from the sludges. The sludges thicken. The thickening process reduces the volume of the sludge to be treated and increases its dry solids content, abbreviated to DSC, for example, from 1% to 3%. Here, you can see a classic thickening process in detail. In the sludge tank, the sludge remains untouched until the heavy particles have sunk to the floor. The so-called liquor or clear water forming at the surface is then withdrawn with a decanter. This creates more storage volume in the tank that can be filled with new sludge. The process is repeated until the tank is full and no more liquor can form. The resulting thickened sludge is of a heterogeneous composition, as shown here. At the bottom is the thickest sludge from the first thickening phase. Right on top, you can still see some of the water in the tank. The DS content might be 8% at the bottom and 0% at the top, for example. For the mass to be pumped off and for a uniform quality to be guaranteed for the following processes, homogeneous thickening is required. This is where the mixer comes into play. Its first task is to produce a homogeneous mass. As the mixer is installed at the bottom of the tank, it moves the sludge with a high dry substance content from the bottom towards the top. At the same time, the thinner sludge with the lower DS content flows from the top to the bottom. When the mixer in our example is started, it creates a homogeneous sludge with a DS content of 4%. After the sludge has been homogenized, the mixer prevents sedimentation. In total, the thickening process takes quite a long time. This can be problematic because the larger the wastewater treatment plant, the larger the sludge volume. Secondary sludge, in particular, occurs very quickly in large volumes. To accelerate the thickening process, larger wastewater treatment plants add polymeric flocculants. They help the sludge form flocks, which increases the weight of the sludge. Consequently, the sludge sinks faster and the liquor can be withdrawn earlier. Polymeric flocculants are not only beneficial for the formation of sludge flocks, they also change the sludge viscosity. The difference polymeric flocculants make is easy to recognize. Both of these jars contain sludge of the same DS content. Let's look at the sludge without polymers first. It's a very thin liquid with disgusting little lumps flowing out of the jar. In contrast, the sludge containing polymers looks and falls out of the jar like potting mix. Its viscosity has been increased by a factor of 20. As you can see, the rheological behavior is completely different, even though the dry solids content is the same. When selecting a mixer, it has to be taken into account that sludge with polymeric flocculants is harder to mix and homogenize. This means the higher the viscosity, the lower the flowability of a fluid, and the more mixing energy required. For this reason, it is of major importance that you know the DS content, the thickening method, and whether polymeric flocculants are used. Large wastewater treatment plants are equipped with a digestion tank in addition. In the digestion tank, already thickened raw sludge is heated up to a temperature of 36 to 37 degrees Celsius and continuously recirculated by special mixers or pumps. In the digestion process, part of the organic mass, approximately 30 to 50%, is decomposed and converted into methane. The gas produced in this way is then used to generate electricity and heat in combined heat and power stations that can be used for the wastewater treatment plant. After the digestion process, The so-called digested sludge is removed from the tank and thickened once again. It's then usually burned. A brief recap. Sludge treatment involves the processes of sludge being collected, thickened, dewatered, and transported away. Wastewater treatment is a complex process in which the water passes through many different stations, including mechanical treatment, biological treatment, and sludge treatment. Today, thanks to Pet & Kofa, we are in a position to offer our treated water in the best quality.